In this video 1-9 we will be looking at patterns, equations, and graphs. By the end of the video on the work time in class, you should be able to say I can use equations, tables, and graphs to describe relationships. A solution of an equation with two variables, x and y, is any ordered pair, xy, that makes an equation true. Is the ordered pair 5, 15 a solution of the equation y equals 3x? So we know that the 5 is x and the 15 is y, because that is true for ordered pairs. So x always comes before y, just like in the alphabet when we have an ordered pair. So we're going to see if it works in our equation over here. Y, which we're saying is 15, equals 3 times x, which is 5. We have 15 is the same as 15, which makes this true. So yes, the ordered pair 5, 15 is a solution. You have 4 more left socks than right socks. How can you represent the relationship between the number of left and right socks in 3 different ways? So I'm going to show you in 3 different ways how we can do this. We will be using x for the right socks, y for the left socks. We're going to write an equation, a table, and a graph to represent this relationship. So for the equation, I know I have a y and I know I have x. Now we know they're not the same. Y, the number of left socks, and x, the number of right socks, are not balanced. It said I have 4 more left socks than right socks. So really right now this is not an equation, they're not balanced. To make them equal, I would have to add 4 right socks, or 4 socks on the right side, so that I have 4 more right socks, and then it would be balanced out. So that would be the equation. Y equals x plus 4, to add 4 more so they're balanced. In our table, let's put x first, y second, and we are going to fill in our table. We'll use 8, 9, 10, 11, and 12. So we are going to put 8 in for x into our equation. So over in our equation, this is where we're going to replace our x value, which is the number of right socks. So if I put 8 in for x, 8 plus 4 is 12. Put in 9, 9 plus 4, 13. 10 plus 4, 14. 11 plus 4 is 15. 12 plus 4 is 16. So that table is representing this relationship. Now we're going to graph it. So on our graph, we're going to graph these ordered pairs over here. So our first ordered pair is 8, 12. So 8, and let's see. Looks like we're going to go off the charts here for this one. So if I had 8, 12, I'm going to go way off. I'm going to be up, probably up around there. So I'm going to, instead of graphing those ordered pairs, I'm going to just graph some basic ordered pairs. So let's say x is 0. So if this is my x coordinate and this is my y coordinate, if x is 0, if I put x into that equation and replace it here with 0, 0 plus 4 is 4. Put in 1 for x. Put in 1 for x. 1 plus 4 is going to give me y equals 5. Put in 2, 2 plus 4 is 6. Put in 3, 3 plus 4 is 7. Put in 4, 4 plus 4, 8. 5 plus 4, 6 plus 4, 7 plus 4. And then you'll see I'm to my 8, 12 ordered pair. And so we see here a line that's graphed to represent the relationship between the number of left and right socks. We have an equation, we have a table, and we have a graph, all representing the same relationship. Inductive reasoning is the process of reaching a conclusion based on an observed pattern. So we're really looking for patterns, and you're going to hear me talk about this a lot in algebra this year. The table shows the relationship between the number of chairs and the total number of legs. Extend the pattern. What is the total number of legs on 10 chairs? So the inductive reasoning is the part where we say, you know what, I'm comparing the x to the y here, and I see that x times 4 gives me my y. X times 4 gives me my y. And it's consistent. That's our pattern. So if I wanted to know the total number of legs on 10 chairs, so I knew 1 through 5, I'm going to extend 10 would be 40. And just using a simple problem with chairs and the number of legs you would have, that's what inductive reasoning is looking for. You're looking for a pattern. Can you say I can use equations, tables, and graphs to describe relationships? Write a summary and reflection and be prepared for work time in class.